A calcium chloride hydrate has a mass of 4.72 grams. After heating for several minutes, the mass of the anhydrate is found to be 3.56 grams. Use the information provided to determine the formula and the name of the hydrate. So this was a lot of information, and now we're going to go bit by bit to see how all this is connected and what all of it means. I've highlighted two key words here, hydrate and anhydrate. A hydrate is a compound containing water molecules, or containing H2O, and anhydrate is a compound without any water molecules. I provided here a formula of what a hydrate looks like. This hydrate is called, or is named, sodium carbonate decahydrate. This is an example of what a hydrate looks like. Because it has 10 water molecules, it contains water molecules. That's why it's called a hydrate. This is what an anhydrate will look like. We got rid of the water part, and this is an anhydrate now. It's not a hydrate anymore, it's an anhydrate. It has lost its water molecules. It's a compound without any water molecules. So it's just called sodium carbonate. Now that you know the difference between a hydrate and an anhydrate, we can now begin to solve the problem. We are going to use a step-by-step procedure to find the formula and the name of the hydrate. Step 1 of this process is to find the mass of the water driven off. So step 1, we're going to find the mass of water essentially. So in order to do that, we must subtract the anhydrate from the hydrate. That will look like this, 4.72 grams, oops, not that, subtracted by 3.56 grams. And we should get 1.18 grams of H2O, grams of water. So this is what we did essentially. We subtracted the anhydrate. From the hydrate. And our overall goal in this step was to find the mass of the water that was driven off. So this right here is the mass of the water that was driven off, 1.18 grams. Now that we took care of step 1, we can now move on to step 2 of the process. Step 2 may be a little bit more difficult, but once you get used to it and you see it multiple times, it should be fairly easy. In step 2, we are going to convert the mass of the anhydrate to moles. The mass of the anhydrate was 3.56 grams. And we're going to put that over 1. Put the multiplication sign, and you're going to put 1 up here. 1 mole, because we're looking to convert the mass of the anhydrate to moles. So what do we put down here as the denominator? That's where the periodic table comes into play. I've highlighted here calcium and chloride. And I've also highlighted these smaller numbers, 40.08 and 35.45. These numbers are going to be important because they signify the mass. And our overall goal in this step is to convert the mass of the anhydrate, which is calcium chloride, to moles. So when you add 40.08 and 35.45 together, you should end with 110.98 grams. You can put CaCl2, calcium chloride, but it's not important or necessary. And set this all equal to your answer. To get the answer, you'll have to do 3.56 grams divided by 110.98 grams. You should end with 0.0321 moles of calcium chloride. So let me just give you a little recap of what we did here. Our overall goal was to find or convert the mass of the anhydrate to moles. So we are converting 3.56 to the number of moles. So we converted 3.56 to this number right here. Now that we've taken care of step 2, and now that we've got the mole part taken care of, converting the mass of the hydrate to moles, we can now move on to step 3 of the process. In step 3, we are going to convert the mass of the water to moles. So in step 2, we convert the mass of the anhydrate to moles. Now we're going to convert the mass of the water to moles. Let me just move this 3 a little bit over. Alright, so the mass of the water was 1.18 grams. So step 1 was important so we can get the amount of grams that we need for step 3. And again, we set this over 1, like we did up here in stage 2. Multiply 1 mole, because we're looking for the mass of the water to moles, so 1 mole. And now we take a look back at the periodic table as we did in stage 2. We take a look at H and O. What's the formula of water? It's H2O. So I'm going to write H2O right here. Now, this is extremely important because many people forget this when solving this. H2. There are 2 molecules of hydrogen. 2 molecules of hydrogen. So I'm going to put this little times 2 sign up here. And how many molecules of oxygen are? Or better yet, the subscripts. We're going to take a look at the subscripts. There's 2, so you're going to multiply by 2. There are no subscripts here, so we're just going to multiply by 1. We didn't have to write this multiply by 1 because it's just the same thing. So if you do 1.008 times 2 plus 16.00, you should ultimately end up with 18.02. 18.02 grams of H2O. Alright, so like in stage 2, we're going to do this. We're going to do 1.18 divided by 18.02. And you should end up with 0.0655 moles of water. So now we have the moles of calcium chloride and the moles of water. There's one more step of the process that we're going to take care of. In step 4, we're going to find the moles H2O to the moles of calcium chloride ratio. So we're going to be finding the ratio of these. So 0.0655 over 0.321. Now why do we set this up like this? Because we're finding the moles of water to the moles of calcium chloride ratio. We're finding the ratio of these two numbers. So we're going to put this on top and this number on bottom. Remember, it's the moles of water to moles of calcium chloride. If you switch those up, you're going to get a completely different answer. So now that we have that, we are going to simplify this. If you do 0.0655 divided by 0.0321, you put that into your calculator, you should end up with 2. Or something, a decimal of 2, but you can round it to 2. It's no big deal. And you're going to set that equal to 1. So 2 over 1 is just essentially 2. So I'm going to bring this down to 2 over 1. Or you can just write it as like this. This is also a ratio. This is a ratio, and this is also a ratio. It's just written in different forms. So 2 mole H2O and 1 mole CaCl2, calcium chloride. This is our ratio to water to calcium chloride. Now that we got that, we've actually solved one part that the problem tells us. We actually found out the formula. We know that there are 2 hydrates. So we can write the formula as this, CaCl2, and then write it like this, 2H2O. We found out how many water molecules. We found out the hydrate part. So this right here is our formula. We just found one part of the answer. The problem also asks us to name the hydrate. So the name of this hydrate would be calcium chloride dihydrate. The di came from the 2 right here, and hydrate came from H2O, because again, hydrate means a compound containing water. And obviously calcium came from this formula right here. So we've just figured out the formula for the hydrate and the actual name of the hydrate too. Calcium chloride dihydrate. CaCl2 2H2O. We've just solved this problem. So try a few more examples and you'll eventually catch on to the process of all of this, and it will just be a lot quicker. Because remember, practice does not make perfect, it makes permanent.